Okay. Is the link okay? NPTEL? हाँ, बट कोई तो आया नहीं अभी तक. 12 लोग in YouTube और टीम में कोई नहीं. Okay, all the YouTubers, welcome to this live session. I find King in Business. He only. Hello, King in Business. Welcome. And other 11, 12 persons whoever are there, welcome to the live session. So you can ask me questions about this Aspen Plus simulation software, a basic course for beginners. Yes, please post your queries because the session limit is only 1 hour. By any chance, Tushar Thakur, are you there? Tushar Thakur or Mohit Gupta? Please respond if you are there. Yeah, Shamrit Tenguria. Shamrit Tenguria is asking, sir, what will be the exam pattern for our course? Exam pattern will be similar to the part A type question that you have solved so far in the assignments. So all the questions will be part A type, not part B type, because you must have noticed that part B type questions, if you want to solve them, then you have to have this software. But in final exam, you will not get the software. So you will be given some questions which you can answer without the software in hand. Okay. So that will be the exam pattern. There will be 50 questions, 2 marks each question, so 100 marks. Shubham Panigrahi is asking how to help Aspen Plus in chemical industry. How to help Aspen Plus? I believe you're asking how you can, or how Aspen Plus will be helpful in chemical industry. I believe you have learned the course so far, so you might have solved, or you might have seen with quite a few examples. So this question you yourself can answer how it can be useful in chemical industry. Okay. Your Aspen Plus is for chemical industry only. Okay, I find Tushar in the MOOC, in the Teams. So Tushar, are you Tushar Thakur? Tushar?
Yes, sir.
Okay. Yeah, Tushar Thakur, I find a couple of questions from you regarding this methanol from syngas and acetaldehyde from ethanol. And you say that you are getting some error messages. Now,
Yes,
I am also a bit confused. How come you can get error message? Because I have performed all the simulation and I have recorded the simulation. So none of them is giving any error. So how come you can get error message? Now there might be only option that there may be a possibility that you have entered some wrong data in your simulation, due to which you are getting the error message. So if you can share your screen, or if you can share your simulation with me through email, then I can check them and I can tell where you are doing something wrong. But it would be better if you scrutinize it yourself first. You can open a window where you can run my lecture, and at the same time you follow the steps word by word. Even if you, if you still get some error message, then you can write to me. I can check your simulation, because without Without seeing your simulation, I cannot advise you anything more.
Okay, sir. I will check once more. But sir, last time also I had rechecked it 1 or 2 times. And I think most of 1 or 2 friends of mine are also getting the same problem. I think it is maybe due to version difference or what, I don't know. But all are getting such same kind of error. So that's why I posted the question like doubt to you.
Yeah, I mean, if you share your simulation with me, simulation file, then I can check myself. That much I can do. Otherwise, it is not possible for me to ask.
Yeah.
Exactly.
Okay, sir. I'll mail it to you.
You mailed it to me? Oh, okay. I might have missed that email.
No,
okay,
I'll check. I will mail it.
Okay, then John Brito is saying that, sir, can you please explain part B question in assignment 9? Part B question, assignment 9. So I can definitely do, but is the assignment 9 questions are out, the answers are out? Because I am not supposed to discuss the assignment. Oh, they are out? Okay. Okay, so I can discuss it. Let me open the assignment 9. I forgot exactly what it is. Okay. So okay, John Brito, are you able to see my screen? I believe all of you can see. Okay, Tushar, can you confirm that you are able to see the screen?
Yes, sir.
Okay. So this is the assignment 9 part B. A stream contains 70% weight of ethyl acetate with remainder being acetone. So this is the feed. You can check the feed. It is 70% ethyl acetate and remainder being acetone. And this is wet percent. 1 kg per minute. And it has to be extracted by 3-stage extraction. All the decanters and feed to the first decanter are 25 degrees centigrade. So 25 degrees centigrade, 1 atmosphere pressure. So this condition has been given. And these are the decanters, right? So decanter 1, decanter. So it is 3-stage extraction process. So decanter 1, decanter 2, decanter 3. And we are extracting using 1 kg per minute of water at each stage. So I have put a duplicator over here. So 1 kg of water. So water stream, you can see that. Yeah, this is water stream. It is also 25 degrees centigrade and 1 atmosphere pressure with 1 kg per minute, and that 1 kg per minute is being duplicated over here. So W1 also is 1, W2 is 1, W3 is 1. So each and every decanter, water at the rate of 1 kg per minute is going in. So this water is extracting ethyl acetate. So this is the extractant and this is the raffinate. So raffinate is, this contains acetone and the ethyl acetate. So ethyl acetate, whichever has been diluted or mixed with water, that will come here, and rest is going through this raffinate. So again, this raffinate is being extracted. I mean, ethyl acetate is being extracted from this raffinate using 1 kg per minute of water flow. So this is the second raffinate, and this is also treated the same way with third stage. This is water, and this is the third extraction, and this is the final raffinate. Okay, so this one we can yeah. So that's how it is. You have to use the NRTL property method. So we have used the property method NRTL, and we have to estimate missing binary interaction parameter using UNIFAC. So we have done that. Binary interaction parameter using UNIFAC, that we have done. So so this is the NRTL. You have used the you have estimated using UNIFAC. Okay. So you can do it once again. Yeah. Now go to simulation. Now decanter. So in the decanter, the temperature and pressure has been given. These are the available components, calculation option, equating components, fugacities with liquid, property method, valid phase as well, liquid. Okay, so this is how you do the decanter extraction. This way how you do the extraction. So this is for decant 1, this is for decant 2, and this is for decant 3. Basically, you do the same thing for each and every decanter. Okay, and then you run the system and you see the results. The results means the stream results. For that, you see the stream. Now, which are the streams that you have to check? So you have to see E1, E2, E3, R1, R2, R3. You can see feed also. So E1, E2, E3, feed R1, R2, R3. So these are the things that you will see. W1, W2, W3, they are all water. So they will be 1 kg per minute, 1 kg per minute, 1 kg per minute. So if you see the mass flow rate, water is 1 kg per minute. So it is 60 kg per hour. Okay, W1, W2, W3. So these are 60, 60, 60. Or if you want to check it with kg per minute, it's okay. Then it will be 1, 1, 1 for all of them. Now, feed is 1 kg per minute as well, but it has 70% ethyl acetate, 30% acetone. So once you mix this feed with W1, that is water, with 1 kg per minute, then out of 1 kg per minute, we had 0.7, so 0.7 kg per minute of ethyl acetate was there, and we could extract 0.10, and rest of the 0.59 it goes through, or 0.6 goes through the raffinate. Okay, so if you compare this with this one, so okay, so here you can see the feed is 1 and W is 1, out of which ethyl acetate is 0.7 over here, and E1 is 0.1 say, and raffinate will have 0.6. So through the first decanter, we could extract 0.1 kg out of 0.7. So this 0.6 is undergone with the second water stream. And what is the result? E2 and R2. E2 is this much, 0.09. It is 0.09. And R2 is having 0.5. Okay, and this 0.5 is again mixed with 1 kg, and E3 is 0.08 or 0.085. And what about R3? It is 0.41. 0.41. Okay, so this is not 6, this is 0. So 0.41. So we carried 0.7 kg of ethyl acetate. After 3 stages of extraction, we are still having 0.41 kg. So how much we could do? We could extract 0.1 plus 0.09 plus 0.085. So nearly 0.2, 0.3, nearly 0.3 kg. Okay, or 0.7 minus 0.41, around 0.29 kg of ethyl acetate we could extract. Okay, so that's what it is. That's how you do this calculation. So did you understand, Brito, John Brito? Okay, then Bhaskar is saying, okay, Bhaskar is asking, so how to add nanoparticles in the components and how to mention nano size range by user-defined XCAO, CUO nanoparticles. Okay, Bhaskar, actually, Aspen does not have any specific subroutine of nanoparticles. Only thing is that you can use all those CaO or CuO, copper oxide or calcium oxide. Those things you can use as solid product. Okay, so you can use the solid material, and Aspen can define those things for, they can be used as solid. So they will have all solid-like properties, and you can specify the size of the solid property. So if it is in nano range, then you can always fix the size as nano size range. But whether it will have the nanoparticle properties like stickiness and all, so those things I'm not sure. I have never dealt with that size of particle with Aspen. So I can answer your question, but then I have to gain some more knowledge on nanoparticles. But to the best of my knowledge, Aspen doesn't have any such specific subroutine for nanoparticles. Okay, so Bhaskar, you are asking how to fix nano size. You cannot find size, okay, fine. Actually, I have not taught that because that is the Solid handling part is, I will cover it in the advanced Aspen class, but I can give you some hint. For that, you have to say, I will close this one and okay. So suppose I opened a new simulation window, say copper monoxide. Okay. So as you have asked, copper monoxide, Bhaskar, I have given that. Now this is conventional, right? This is conventional. That means copper monoxide, along with all its chemical properties, it will be taken. But as you are saying that it is nanoparticle, so it should be solid. So you can define them as solid. Okay, so this is solid. The moment you use solid, then it will be regarded as solid, not a conventional particle. Now, for solid handling case, there are ways that you can define, but the best way to define the method name is solids. And go to the simulation. And here you have to choose the stream class, which is not conventional. Rather, you have to choose something like mixed stream, that means which is having liquid, vapor, everything, as well as some non-conventional solid. Okay, NC means non-conventional solid. This one is mixed stream, that is if you have vapor, liquid, etc., along with Cl solid. That means when you have conventional solids like that copper monoxide, which you have just now told, but it does not have any particle size distribution. Or you can use mixed Cl solid, conventional solid with particle size distribution. So if you do not have particle size distribution, you have to choose this one. If you want particle size distribution, you have to use this one. Now suppose you choose this one. Okay, then you have to give the particle size distribution. Now as you are saying it is in nano range, then probably you can use it in angstrom or micron. Okay, now suppose it is in micron. Okay, whether you can use micron or you can use mu, whatever. And the particle size mesh type, you can use the equidistant or you can use geometric, logarithmic. Now these are the things that you will learn in an advanced way. Now suppose you use equidistant, then you have to give the lower limit and upper limit, say 0 to 50 micron. I do not know what is the nano size that you are looking for, say 0 to 50 micron with number of intervals 10. So it will be 0 to 5, 5 to 5 to 10, 10 to 15, like that. So you create the PhD mess. So the first interval is 0 to 5, second interval is 5 to 10, third interval is 10 to 15, and so on. And when you fix that, if you go to the flow sheet, now these are the solid things like crystallizer, crusher, screen, okay, solid washer. So in the first course of Aspen Plus, I have covered mixer, splitter, separator, exchanger, column, reactor, pressure changers, and some manipulators. But I have not used this solid separator, etc. So in the advanced course, I will use this one. Suppose you use crusher, okay, or if you use screen. So if you use crusher, you can enter the feed like that and like that. And just as you do the conventional one, you have to give mixed feed. Now here you do not have any vapor or liquid or anything like that. Rather, you have solid feed. So the solid feed you can give, say, 25 degrees centigrade, 1 bar pressure. So normal temperature and pressure. And mass flow, you can say 10 kg per hour. And here you have to give the particle size distribution. So the particle size distribution, already you have created 0 to 50, 50 to 10, 10 to 15. Now you have to say weight fraction. What is the weight fraction of the different intervals of the weight fraction in the different intervals of the particles that you are having from 0 to 50. Now you can do the user specified. So you can say, well, I have 50% particles over there, and then 10% in the range of 5 to 10, then 0 or 2% in the range of 15 to 20. Like that you can give up to 50. Or you can say I have a distribution function, which is a normal distribution function with, say, standard deviation and D50. D50 is the 50%, the mean. Okay. So 0 to 50, let us say mean is somewhere around 30 micron, and the standard deviation may be, say, 1 point or say 5 micron or so. Okay. Now you calculate. The moment you calculate, the weight fraction will be seen over here. Now see, the particle size distribution has been given over here. Okay, so this is the inlet particle size distribution. So that inlet particle size distribution, here you will have the table. So this is the weight fraction of each and every. So this weight fraction has been calculated using the normal distribution. This is absolute weight fraction of particles between individual interval, and this is using cumulative weight fraction. And they have D50 of 30 micron and standard deviation of 5 micron. So you can see the 30 micron range, so that is the D50, 50%. Okay, this is the D50 at 30. So like that you have to fix the particle size distribution. Now this way you have to handle the solids, and it has more details into it. So I have not covered them in the first course or basic course of Aspen Plus. So this I will cover in the advanced course of Aspen Plus. So I believe if you follow the advanced course of Aspen Plus, I mean, if you take the advanced course of Aspen Plus later, although I have not floated it yet, but I will do it as soon as I can prepare the video lectures. Then you can learn it better, and I'm sure you will be able to use the kind of nanoparticles that you want. Okay. Till then, you have to wait. Okay, Bhaskar? Fine. So Arju is saying you discussed about methanol from syngas. I'm trying to ethanol from syngas. I have only following reactions. In my case, water is also in the reaction. Could you please help me to solve it? First, I have to try out myself, you know. Without trying out myself, I cannot give you advice. So you can give those reactions to me through email, Arju. My email address, you must be knowing by now. It is p.saha@, sorry, it is not Gmail, it is IITG.ac.in. Okay, p.saha@iitg.ac.in. So you please write an email through this. You can email your requirement. I can solve the problem myself, and then I can advise you further. Okay, Bhaskar is saying, sir, actually I want to use copper monoxide nanoparticle CuO plus base fluid as catalyst to a reaction. Is it possible? Well, catalyst, obviously catalyst is possible. In that case, this will take part into the reaction, right? This is always possible. In that case, you have to give the total reaction. The way Arju has given this reaction, so you have to give those reactions. In that case, you do not have to do all those solid handling. Probably my last 10 minutes of discussion has gone to the waste. If you would have told me that you are using it as a catalyst, then my discussion would be different altogether. Yes, then you have to use it as a catalyst, and you have to mention the weight of the catalyst. Okay, so the reaction will not be volume dependent, it will be weight dependent. So weight of catalyst per kg. Okay. Arju is asking, is there any concept of hydrojet nozzle? Hydrojet nozzle? No, not anything that I know of. So Bhaskar is asking, sir, if I mentioned weight of catalyst, but it is in normal range, how can be it nano, sir? Could you explain? So that's what I'm asking, Bhaskar. You are probably you are confusing between the two. Basically, when you are saying that you are using nanoparticles, that means your reaction probably is occurring on the surface of the catalyst, right? In that case, it is some adsorption is happening on that catalyst. So that's a different concept altogether. So it is reaction plus adsorption that is happening. That much I can understand. So it is not like copper monoxide is directly taking part on the reaction. So if copper oxide is taking part on the reaction just like a catalyst does, then it is weight based. But if something is being adsorbed on the surface, then can you call it a catalyst? I'm a bit confused over here. When you are using nanoparticle, that means it is you are trying to use the surface phenomena of something that is occurring over there. So that thing is not handled so easily or in such a straightforward manner by Aspen Plus. Okay. Arju is asking, sir, I am trying pyrolysis of biomass using Aspen Plus. Result shows high energy consumption to pyrolyze, while IIC shows less. Why? I don't know. I mean, HiSys is a different software altogether. And I do not know what are the inputs that you have given over there in Aspen Plus. What are the inputs you have given in HiSys? So how can I give you any straightforward answer to it? I have not seen your simulation, right? Sai Kumar is asking, sir, can we add enzyme lipase in the component list? Actually, I'm trying to do enzyme catalyzed biodiesel production. It should have a proper name. I mean, if it's a component, some scientific component, then definitely you can. I do not know about this particular enzyme that is called lipase. If lipase is there, let us check whether lipase is there. No, it's not possible. It's not there, Sai Kumar. Again, Arju is asking which is the best reactor in Aspen Plus to produce syngas from biomass. I don't have any exact data of reaction kinetics. Okay, Arju, Aspen Plus is not an engineer. Aspen Plus is a computer program. You are the engineer, so you have to know all those information. Aspen Plus will not tell you. Categorically, if you have to perform some simulation, now whatever, suppose Aspen Plus doesn't exist, you are supposed to write your own code and run the program and get the simulation result. Aspen Plus has made your life simpler, but it has not replaced you. Okay. So this particular questions do not have any meaning. Okay. So you have to have those information. You have to have those data of reaction kinetics. Then only you can say that this is the reaction kinetics, so plug flow reactor is better, or the CSTR is better, or this thing is better, that thing is better. So you have to have the complete information about it, right? Sai Kumar says it is in PubChem. Yeah, it may be in PubChem, but it is not in there in the list. You see, the name alias or CSRN lipase, there is no result, so it is not there. I mean, something which is not there over here, in that case, probably you can. Okay, I believe this is the one which you are looking for, right? So we just add them. So you have to give certain parameters like what is the normal boiling point, critical temperature, critical pressure. Okay, so those are the things that you have to do, and you have to give. So you have to, or you can estimate all missing parameters over here. Yeah. And if you are not using it as a solid material, then you can use it as a conventional, and yeah, so it is available. You can do it now. Okay, Sai Kumar. So what was your question? As you estimated parameters, you got warnings for that. But I didn't get any warning. I got results. Sometimes you do something which I'm not sure how you do it. Unless I see myself your screen, I'll not be able to answer what is going wrong at your end. By any chance, Mohit Gupta is there in the... Mohit Gupta? He asked me some question, so I thought I will discuss it. Okay, any more question you have, learners? Okay, M. Teja is asking how to add raw materials and product cost for economics. No, something I have not covered over there. Did I cover those things? They come under the advanced level subject. So I will cover all of them in advanced Aspen Plus. Okay. Okay, so learners, thank you for interacting with me in this live session. Well, Teja, I cannot give you hint because I have to teach you. And I'm sorry to say that you are not supposed to do any project with the help of this Aspen Plus simulation software unless you have the software yourself, because this simulation software which you have got from our side, you have signed a declaration form that you will not do any project which is outside the domain of learning this software. Okay. So if you are doing any project and you are taking the help of this Aspen Plus license, then you are doing something which you shouldn't do. Arju is asking, dear sir, try to launch advanced Aspen Plus course. Yes, Arju, I am preparing the lectures. My progress is very slow, but I will definitely try to do it as soon as possible, and I'll float this. Okay. Teja is saying, I have my own software, just asking. You mean to say you have your own Aspen Plus software? Oh, great. Okay, so already 4 o'clock. So thank you for coming to this live session. And if you still have some queries left, you can write to me. You can contact me through email. Okay. So, NPTEL, you can close this session, please.